Hello everyone, welcome to another video. Today let us see about recursion. We can solve a problem in Fibonacci series. Normally they would have defined recursion as a function that calls itself. It's a wrong definition. A function will never call itself. The actual definition is it is a function that calls copy of a function of the function. So what do you mean by that? For example, you have a function. You are defining the function. Okay, you are passing some argument, blah blah blah, some statements, and you're going to return. You're calling the function maybe n minus 1, something like that, right? People would have thought that this function will call the same function repeatedly. No, it's wrong. It copies whenever a function is called. It copies in this stack. So basically, it will recreate the function return of function of n minus 1. So when a function is called, it will call a duplicate function. It makes a copy and calls the function. So in recursion, the most important thing is to find the base or exit or termination conditions. Because if you maybe wrongly estimate the base condition or termination condition, it will end up in stack overflow. Why it is a stack overflow? Because keep on looping while each iteration, right? 1, 2, 3, each calling of a function, it'll keep on creating multiple functions. So again, def function, it'll keep on, it'll be unlimited, infinite loop, unlimited, or it could be infinite. So that only you have to fix the base or termination condition in any recursion recursion when you handling a recursion. In this session, we are going to solve a problem. A problem is like to find a Fibonacci series. That is, you are aware of Fibonacci series. Anyway, I'll repeat. The Fibonacci series may start from 0 in some case study. Maybe it starts from 1. In our case study, we can say that it starts from 1. Okay, uh, 1. So initially it starts from 1 1. How to generate the a third number? It is previous two number. So here I equal to 1, right? I'll use a different color. Equal to 1. 2. How to get the third number? How to get the third number? Assume it is I equal to 1 2 3. How to get the third number? To get the third number, it is addition of previous two number, that is 1 plus 1 2. How to get the fourth number? It is previous two digits, right? Previous two Fibonacci series, that is 2 plus 1 3. I'll use the same color, 3. How to get the fifth position? The previous two numbers. How to get the sixth position? The previous two numbers. That is 5 plus 3 is 8. 8 plus 5 is 13. 13 plus 8 is 21 and goes on, right? So these are positions. So if I pass in a Fibonacci, let us assume it is n, okay? N equal to 1, 2, 3, 4, 5. These are pointers, okay? Pointers. So input will be I, that is n, could be 6. Then I should get the output as what? Whenever the value is, I want to get this series, that ith place or the nth place of the Fibonacci series, 8. When input equal to 7, that n equal to 7, then I should get return Fibonacci series, that is a function, right? It is a Fibonacci series of 7. If I pass, I should get 13 should be the output, that is fib of, right? fib of. Suppose fib of 4, then I should get 3. Here, as I mentioned, what is the most important thing? To find the base condition. You know what? What is the base condition? What is the termination condition? Very easy, right? So in the Fibonacci series, the first two digits are given. That is, whenever n equal to 1, that is fib of n equal to 1, it will return what? 1. It is already given. Similarly, fib of n equal to 2, 2 is passed in the Fibonacci function, it will return 1. These are the two base conditions, right? Now, if I want to pass 3, fib of n equal to 3, then what should I get? I should add the previous two number, that is fib of n minus 1, okay, fib of n minus 2, okay. So that can be summarized as, I will simplify it, fib of 2 plus fib of 1, right? So you already found fib of 3. So this is 1 plus 1 is 2, will return 2, right? Now how to find a fib of 4? Whenever it want to find the fib of 4, it is previous 2, that is fib of 3 plus fib of 2. What is fib of 3? Already it calls fib of 2, okay, plus fib of 1, okay, it returns 2, okay, plus fib of 2. What is fib of 2? 1 equal to 3. Let us take one more. Fib of 5. It is fib of 4 plus fib of 3. You already know what is fib of 4, that is 3. Okay, it again recursively calls. Okay, to find this, it recursively calls, right? Fib of 3. What is fib of 3? Is 2 is equal to 5. It is recursion. It is a iterative process, right? Hope you understood. Let us draw the or define an algorithm. Okay, algorithm. Very easy. We have to simplify it, right? The first thing is to find the base condition or the termination condition. So what is the base condition? If n double equal to, if sorry, yeah, if n equal to 1, I should return 1. If n equal to 1, I should return 1. Then if n equal to 2, I'll return 1. Else if n equal to 2, I'll return 1. Else what I will return? Return what? Simple. Fib of n minus 1 plus fib of n minus 2. That is fib of n minus 1 plus fib of n minus 2. Very simple. So this is the function, right? Def fib of n. This is the function. Let me again rewrite this function, right? So def, and keep on simplifying the function, def fib of n, okay, if n equal to 1, or okay, or n equal to 2, I'll be returning 1. Otherwise I'll be returning fib of n minus 1 plus fib of n minus 2 simplified. So this is the recursion function. This will do the entire trick. Okay, this is how you have to define the algorithm. Let us draw the diagram, right? Tree diagram, tree structure, right? Let me draw. If I pass fib of 1 to this function, right? What will return? It will return 1 because n equal to 1, it returns 1. Let us pass fib of 2, passing 2, then it return 1. Now fib of 3, If fib of 3 is called, so it doesn't satisfy. What happens? So 3 minus 1, it calls. So fib of 3 minus 1 is 2. Fib of 2 is written, it returns back, right? It backtrack. Okay, it branches out and backtrack. Again, right hand side, satisfied. Fib of 3 is passed, left hand side is over, right hand side it is coming. Branches out. So fib of 3 minus 2 is 1. Whenever you passes 1, it returns 1. So function stops. It return backs, drills down and return back, right? So it returns 1 plus 1 equal to 2. Simple, right? We can write a Fibonacci, draw a Fibonacci for maybe I'll take one more sheet. So let us draw for fib of, we have already seen fib of 3. We can see fib of 4. Okay, fib of 3 and right hand side it will be fib of 2. Again left, first it will come through left hand side. Okay, let me branches out only left hand side. Okay, fib of 3. Again it branches out because the algorithm is like comes left hand side, left hand side, left hand side until it overs branches out left hand side, then right hand side, right? So left hand side again fib of 2. Whenever it is 2, it stops. Branches, branches, it condition satisfied according to the algorithm and comes up, right? Then right hand side. So this is fib of 1, right? Again, it comes up, branches out, comes up and comes up, right? And branches out again. Fib of left hand side, it 3 is over, now 2. Whenever you passes 2, the condition satisfies, branches out and return backs. So here it will be 1 plus 1 equal to 2, right? So your right hand side, left hand side computed, again 1. So 2 plus 1 is 3. Let us assume 3, right? Whenever you passes 4, you will get the answer is 3. Good. Let us take one more, fib of 5. Let me keep branching out, branching out, branching out, right? Stops because 2, whenever passes 2 or 1, returns 1, right? Then right hand side, fib of 1, right? Then again comes up, again fib of 2, stops again because 2, 1, 2, whenever passes 2, 1, 2, it stops. 2 or 1, it stops because it returns 1. Otherwise, it branches out, right? Right hand side, fib of 3, okay, again branches out. Fib of 2 and fib of 1 stops. So how it comes? Let us trace it. Branches out, okay, branches out, branches out, backtrack, branches out, backtrack, backtrack, branches out, backtrack, backtrack, branches out, branches out, backtrack, branches out, backtrack, backtrack. Let us solve. This is 1 plus 1, right? 1 plus 1 equal to 2. So 2, again it returns 1. 2 plus 1 is 3, right? So 3 found. Fib of 4 equal to 3. Again 1 plus 1 is 2. So 2 plus 3 is equal to 5. Whenever you passes 5, I think it will return 5. So this is branching out. Normally this is called as back backtracking algorithm in algorithmic strategy. Don't forget this one, right? Next class I will be telling you about how to find the time complexity for this particular problem. Check out my next video. I'll publish it very soon. Now let us get into programming. I'll open my Visual Studio to solve this problem. Sorry for that one. Yeah. All right. So what is the function? I'm just copying it. Def fib of, I'm passing n. All right. So what is the condition? If n double equal to 1 or n equal to 2, it returns 1. Always input should be a positive number, not 0 or less than 0, right? Remember that one. Return fib of n minus 1 plus fib of n minus 2. Okay. So let me call f equal to fib of, let me start passing 1. Let me print it. I'm using uh, I'm using Python. You can also use Python programming language, or you can use a different C. I prefer Python. And as a beginner, I suggest you to use C programming. Anyway, um, let me run this program. Yeah, whenever you passes 1, you will get the result 1. Whenever you passes 2, let us see the result. Again, you will get 1. Whenever you passes 3, you will get result. Yes, 1 plus 1 is 2. Let me pass 4, 3. Okay. I think if you passes 5, you will get 3 plus 2 equal to 5, right? When you pass 6, I am passing the position in order to get the answer. 8. Let us find a Fibonacci series for maybe um, ninth position. 34, obviously. I hope you understand the problem, how to solve it. The basic thing is to find the termination condition. And in my next session, I will inform you how to find the time complexity. For example, how many times this function has been called. I'll print hello. Okay, let me give a simple 5 as an input. So how many times it is called? 1, 2, 3, 4, 5, 6, 7, 8, 9 times it has called. Okay, 9 times. Let me put 6. So how many times it had called? Mm, many times. You can calculate, guys. Thank you. Thank you for listening. We can see in the next class.